stream just decided to, my whole computer just decided to crash to log in, which really it doesn't do that most of the time. So I don't know what is going on tonight, but tonight it just does not want to cooperate. If this does happen too much more, I will end up just probably signing out and doing something else, but where were we? Yeah, something like that. Biblical Truth A by Gregor Narholz. Interesting. Yeah, so we're gonna... Apparently an ad's gonna start in a minute. Jerks. Alright, we'll snooze it. We'll just snooze it to 15 minutes and then play like a 1-minute ad, because that's just stupid. Okay. So let's get Excalibur back. Righto. So hopefully this will remain and not crash again. We'll see how it goes. Alright, find the exact value. Of the following. N goes from 2 to infinity of -1 to the n, pi to the 2n plus 1 divided by 2n plus 1 factorial. Okay. So this is going to be a Taylor expansion, or so it looks. Next question is which one? So... Right now we have odd powers. Odd powers divided by odd factorials. Yep, there it is. Okay. So... Excuse me. Okay. The sign of x is equivalent to n goes from 0 to infinity. Of -1 to the n times x to the 2n plus 1 over 2n plus 1 parentheses factorial. That should be correct. 2n plus 1 factorial. 2n plus 1 is an exponent of x. That is the sign of x. Yes. Alright, so this is actually a Maclaurin polynomial, but yeah, whatever, it's fine. This is then going to be equal to the sum as n goes from 2 to infinity of negative 1 to the n x to the 2n plus 1 over 2n plus 1 factorial plus, what do we get when we plug in 0 for n? N equals 0 is going to get us a 1 times x to the 1 over 1 factorial plus, what do we get when we plug in 1? It's going to get us a negative 1 times x to the 3rd power over 3 factorial. Okay, so this is going to be sine of x minus x to the 1st minus plus x to the 3rd over 3 factorial is going to be equal to the sum as n goes from 2 to infinity of all that stuff. So negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Okay, so from what we had up above, this is the exact same thing. The only difference is that we don't have an x, we have a pi. Therefore, all of this was plugged in. So this is the sine of pi minus pi plus pi to the 3rd over 3. Sine of pi is 0. So our exact value for this is going to be pi to the 3rd over 3 minus pi. That felt like a real easy one. So, uh-oh. Oh, 3 factorial. Right, I even wrote it here, so I had to be more careful, kids. Right, or then we can expand that out and say it's not 3 factorial, it's 6. Which is in fact what they did here. Pi to the 3rd over 6 minus pi. Cool. Let's see if we can do this one. A first sequence of letters is constructed as follows. 1. Begin with a single ampersand symbol. Approximately. Every occurrence of the ampersand symbol is replaced by the word ampersand. Every occurrence of the word and found anywhere is replaced by the ampersand symbol. Obtain the resulting periodic sequence of symbols a sub n with period p. from a sub n, construct a second sequence, b sub n, defined by b sub n is equal to 10 to the n minus p floor times the floor function of 10 to the n over p. Here the brackets indicate the floor function that yields resulting value bn is the usual remainder upon division of 10 to the n by p. Fair enough. What is the value of b sub 1000? Alright, step 1. Write an ampersand. Replace ampersand with the word ampersand. Replace any instance of the word and within the string with ampersand, and then repeat. So, oh no. You know what? Let's do this. G drive. Okay, good enough. New document. Okay, so ampersand. Find. Do we? Nope, that's not what I wanted. Ugh. It's alright. Search. No. I mean, I could do Control F, but I wanted to. Yeah. Find ampersand. Replace with ampersand. Replace all. Find and replace with the ampersand. Replace all. Find ampersand. Replace with ampersand. Find and replace with this. Replace all. Okay, so it's just taking that last one as the only. Yep. Okay. So a sub 1 is just going to be the ampersand symbol itself. A sub 2 is going to be the word. Ampersand. A sub 3 is going to be ampersand. A sub 4 is going to be ampersand. A 5 is going to be and so on. So A6 is going to be ampersand. And now we're on an ad break. Yay. The advertisers might hate me, but you know what? I don't care. Don't buy crypto. Don't invest in it, because it's not an investment. You're just pissing your money away. You'd be better off buying a whole bunch of apples, planting a bunch of them in little pots and seeing which one of them grows, and then planting that outside and selling your own apples in 10 years. Alright, so we want B sub 1000. Which is going to be, what is the remainder of 10 to the 1000 divided by P? My goodness, this is very intense music. I don't think it's quite worth all that, but... Okay. On odd numbers. And for even n, we see n over 2 amperes plus and all the way at the end. I mean, it looks to me like this is period 2, but obviously I'm not understanding what's going on here. Okay. I don't understand where... I see there's a claim that somebody's making. Okay, you can prove that this always works via induction. So, if we start at the beginning, we see an ampersand, and then that ampersand becomes the entire word ampersand, and then the and becomes the symbol becomes the word, okay, symbol becomes the word becomes the symbol. That should be it. We need 2 steps to do this. Somebody's making a claim that this needs to be period 6, and I am not seeing that. If anyone has any ideas, feel free to drop them in chat, because I'm kind of stumped as to why it's not period 2, I guess. The symbol becomes the word, the little miniature word becomes the... Yeah. Symbol ampersand becomes the word ampersand. The word and becomes the symbol ampersand. And then we're back to the beginning again. So we need like 3 objects anywhere in order to show anything. Or are they saying that because this is a period 3, or because we need 3 items in order to prove this, that we then actually have period 6 because you need to do induction on that block? I don't like that. And even if it's true that we need like the block to then show the full pattern, then surely we're saying like 1, 2, 3, and then 3, 4, 5 would be the next few steps to end up back where we were. Hey, Elysium, yeah, my computer just decided to freeze OBS, and then it like died. I'm not sure exactly how. So I just dropped OBS entirely, and then like restarted OBS, and then I went up to restart OBS, and like the entire computer froze and it dropped to login. This happens very rarely, but it still happens occasionally, and it's really frustrating from my perspective. So, sorry about that, but I don't know what happened. But then we, yeah, we were able to get everything back up and running again, and re-logged in and all that. So, weird. Superbrain, isn't it true that n plus 2 has 1 more ampersand than n has? Yes. Or ampers. Yeah. So my contention is that the period should be 2. But this is saying you need a period 6. No, but we returned to a previous instruction, and I'm not sure if I'm just reading it wrong. Okay, so I still don't like this. Okay, so what I'm seeing here, right, the claim is that for all n in the naturals, that's not natural. A sub 2n minus 1 is going to be equal to however many amperes we're going to have, followed by the ampersand symbol. And a sub 2n is going to be this, where the number of amperes substrings are going to be here n minus 1 and here n. Now, I don't think that there's any issue with that. I mean, that seems to be clear enough. Now, the next part is they say that this is going to be proved using induction on n. Right, so n equals 1, we did that up above, where we said if n is 1, we have here, wait, that n is 1. So it's going to be 1 and 2, right? Some number of amperes followed by an and. In this case, none. N minus 1, n was 1, so therefore there are 0 amperes followed by the ampersand symbol. Then at 2, we just have the ampersand word, which is 1, which is half of the index that we're on. So again, fair. That's how that works. Then we're going to assume this is true for all natural numbers less than whatever that n we've chosen is. As long as, again, all of those things belonging to the natural numbers. Fine, whatever. So if that's true, then it's going to be true up to a sub 2 parentheses n minus 1 minus 1 and a sub 2 of times n minus 1, which is then going to be a sub 2n minus 2 minus 1 is minus 3. And then this is going to be a sub 2n minus 2. Okay. I think I get it. Yeah, if we're going to use induction... Hang on. Yeah, I'm still going to contend with the fact that I don't know where they're getting 6 from. Because here, we're using 2n minus 3, 2n minus 2 to get our cases for n minus 2, n minus 1. That's going to get us our induction step for a sub 2n minus 1 and a sub 2n, which correspond to n and n plus 1. No. They're going to correspond with m minus 1 ending in a symbol and n ending in and. But that's still only 4 things. It still only give us 4 terms that we're actually talking about. Because we don't have to prove it for n plus 1. If we assumed it's true through n minus 1, and then we have to prove it to n. Yeah, I don't like it. I think I'm just going to turn the page and move on, because maybe if one of our other friends come in and know much more numerical analysis than I do. Alright, 95. A game consists of a sequence of plays. Okay, so we're going to do a Markov chain. On a play, either you or your opponent scores a point, you with probability p less than half, and opponent probability 1 minus p, then greater than a half. The number of plays will be even, 2, 4, or 6, etc. To win the game, you must get more than half the points. You know p, and you get a prize if you win. Choose the number of plays. How many do you choose? Okay. So every time you do this, U with probability P less than a half. Let's go like this. Right, this is going to be our probability table for each of the 2 plays that we get. And all that has to matter is we have to get more p squareds plus 2 p times 1 minus p compared to parentheses 1 minus p squared. Okay. So let's assume here for the moment. Either you or your opponent scores a point. Like, all we need to really do is just keep drawing over and over and over again in every round. You get to choose the number of plays, so you decide how many times you're going to decide ahead of time how many plays we're going to do, and then you have to maximize your own win despite the fact that your likelihood to win is less than 50%. If anyone is waiting, feel free to drop any questions you might have in chat. We don't have anyone currently asking any questions, but if you want, you can either just ask the question or pop it in the queue, because thank you, Enigma, we have a queue. This is going to be $, and the letter Q, or $ followed by the word Q, Q-U-E-U-E. So one or the other. Okay, that felt weird. I thought my tablet was plugged in wrong, but like, I don't know how you could plug it in wrong and still have it work. Hum. So, like, again, we have to keep winning or tying as many times as we need. The issue is that if we end up losing one, it's going to be unlikely for us to win one back. Not impossible, just, you know, not particularly likely. So, we want to know how likely... Where do we want to end up on this thing? Okay, so good news, I am uniquely positioned to solve this. Because I did some research into the so-called Pascal's triangle. And in this case, that is actually the appropriate name for it, because we're talking about probability theory. Okay, so what we're trying to do is we're saying, like, what row do we want to end up on such that it is most likely for us to be given the edge to be able to win. So, if we were to end up having... Right, this is the way that the triangle goes. Six, 15, 20, 15, 6, 1. Alright, one sec. Okay. So the game can end after an even number of trials. Which means that we can go, again, 2, 4, or 6 plays to make it to the bottom there. Same chord progression. 56, 70, 56, 28, 8, 1. Okay. Which everybody says, like, you know, Pachelbel's canon's one of the ones where you just always get the chord progression. Everybody always does it. It's kind of overdone. They didn't have to be so obvious about it. Okay. So if we end up with number of options that we get are going to be, we're going to win if we get the sum of the row right, we only get a 1 win, 2 ties, and 1 loss on P equals 2. Probability, no, not probability. The total number of plays being 2. Total number of plays being 4, we're going to get 5 and 5 on wins and losses. And a tie of 6. So let's see, 2 is going to be a 1 in 4 chance of just straight up winning. Probability of win, oh, lowercase. Probability of win is going to be 1/4. Probability of win down here is going to be 16. That's 5/16, which is a slight improvement. All right, down here we've got 21, 22, 20, and 22. Probability of winning, again, is going to be 22 out of, and we'll just leave it as the total number here. That's 64? Yeah. I like powers of 2 in the denominator. Let's not simplify. Let's just leave it as is. But 22 out of 64 is... Let's see, 1/4 is 16 out of 64, so it's actually a significant improvement. And then down here, this is 70. And we have 9, 37, 80, 93. So this win probability is 93 out of 186 to 56. Right, yes, of course. Quarter of 256 is going to be 64. Yeah, right. It's the previous denominator, right. So 64 out of 256. This is again a marked improvement to 93, and is, I don't know offhand like where that particular number is. 22 out of 64 is 34.4%-ish. 93 out of 256 is a 36.33%. So again, fairly significant improvement. 1, 9, 36. I don't usually go this far on the triangle. 84, or I just let the computer do it. 126, 126. Symmetric, 84, 36, 9, and 1. 10. 1, 10. 45. 120. 2, 10. 2, 52. 2, 10. 120. 45. 10, 1. Which makes tie 252, and win and loss are both going to be yep. 330, 340, 385, 386. So that's a 386 out of 1024. So pretty close to 38%. 37.69, 37.70. Right. So 25%. This one's going to be 37.695%. 93 out of 56. 36.328. 22 out of 64. 34.375. And 5/16, 31.25. So we've got a, let's see, probability In the following configurations, they say. Ooh. About to crash again, maybe. Firefox is dead. Alright, well, we'll see if this actually continues or if we're completely toast here in a second, but well, it's been a nice night, everybody. Oh. Alright, well, yeah, my computer is now completely frozen except for my like OBS. I can see it moving, and I can see that over on the stream over on my monitor that I'm still moving, so that's good. That's going to change at some point, I'm sure. Hooray. And nope, can't Alt-Tab or anything like that. Oh well. That's really frustrating. So, we can talk a bit. I can also see chat. I just can't do anything in my actual, on my actual computer till it decides to either kill the stream entirely or I do something on my OB account. But nonetheless. You know what? I can't actually raid, can I? That's kind of frustrating. Anyway, so for this particular case, we've got to look at the different ways in which we could win, and specifically win, right? We don't want to end up tying. So this is saying that from the top, right, the probability of us winning is going to be 1 times p squared in 2 plays. In 4 plays, we go 2 rows down, and we've got 1 p to the 4th plus 4p to the 3rd times 1 minus p. That's how we're going to do this binomial, through a binomial distribution. And then our 6 is again a tie, and then the 4 and the 1 on the right-hand side are losses, so we want to skip that. With n equals 6, we got 1 p to the 6th plus 6 p to the 5th times 1 minus p plus 15 p to the 4th times 1 minus p squared. And then 2 more down, n equals 8. We've got p to the 8th plus 8 p to the 7th times 1 minus p plus 28 p to the 6th times 1 minus p squared plus 56, 56 p to the 5th times 1 minus p to the 3rd, and then we could go to 10 at the bottom. It's going to be 1 p to the 10th plus 10 p to the 9th 1 minus p plus 45 p to the 8th times 1 minus p squared plus 120 p to the 7th times 1 minus p to the 3rd, and 210 p to the 6th times 1 minus p to the 4th. So we've got all of those values, and then we say for what values of p is right, for what values of p, our probability, will any particular number of plays be better than the line 2 above it. So if we go to between the 2 plays and 4 plays, right? We're going to do for what values of p will p to the 4th plus 4 p to the 3rd times 1 minus p minus p squared be greater than 0. Right, so we're essentially doing like a how many points are we going to get compared to 2 lines above it. You know, this happened like a month ago, and now I don't remember how I fixed it. It was not through... Well, I got my mouse, but I can't actually do anything with it. I also can't go to the terminal. Or again, can't Alt-Tab. Can't hit the Windows thing to pop it out. Can't Control-Delete because it's Linux. Okay, so for when will this happen? If we expand everything out, we can get 0 product property, and this will be a, let's see, negative p squared times 1 minus p times parentheses 1 minus 3p is greater than 0. So then when's that going to work? So it says here that as long as your probability is low in winning at all, and this is somewhat intuitive, if your probability is extremely low, you should just play 2 games and get out as fast as you can. So even though, right, 25% are, let's say at 10, n equals 10, if you play 10 rounds, you've got a 38% chance of getting more games or having more outcomes in your favor than the other person. The problem is that this was agnostic in terms of the probability of you winning. We didn't incorporate that into this yet, and that was really what I need to write. Hat dance? Really? This has got some weird stuff on it, I swear. I was playing Christmas carols the other day. Should be able to lock out Christmas carols until after Thanksgiving. That's an old man Obi hot take for you. Yeah, so if you have a very low probability of winning, you should do as few trials as you can and get out fast as you can. If you have a fairly high chance of winning, and by high chance I do still mean it's less than 50%. But the more even that it is, if you're at like 49.8% chance of likelihood chance of winning, you probably want to play as many games as you can. And there is a particular optimization that you can get for that based on this stuff. So we could potentially do this either on Desmos or Wolfram, or just by working out what the zeros of these polynomials are. shouldn't be particularly hard, but nonetheless, we find the zeros for all of these individual numbers, and then we say, okay, if these are the zeros, then if these are the zeros, then we should be able to find our like boundary regions where it's going to be acceptable to have this particular setup. So for 2 versus 4 games, basically the region that we care about is when our polynomial comes back up above 0, and that's going to be at p equals 1/3. So anytime after a probability of 1/3 of you winning, you're going to want to play more than 2 games. So play 4 games. But then you say, well, what about 6 games? And you can do that probability again. Just keep running through and find out where your optimal path lies. So it turns out they have here that you want to switch to 6 games at a probability of 2/5 or 0.4 of you winning. You want to switch to 8 games at a probability of 3/7 of you winning. And you want to switch to 10 games at a probability of 4/9 of you winning, or 44.4 repeated percent. So those are the values where you want to switch. I don't actually know what 3/7 is offhand, but 42.8586. And then the person who was solving this did it in general, and then was able to get a generalized polynomial that says your probability should be between this and this for your probability of winning p. You have bounds, and then you have your n in between. So that's pretty cool. I wish I could actually do it out, because, you know, it'd be kind of nice. So we're going to put this one back. Righto. I think we're probably going to just call that a night and go see Dawn, because Dawn does math. And currently, Dawn's probably working on a... Wait a minute. I have a Dawn system. Next question is where to go. Ah, it's underneath there. And also, I have markers somewhere. And again, if anyone has any questions, feel free to drop those in chat. I will see it, because I do have a secondary chat monitor. I had more markers. They're right here. There's a bag. It's not in that bag. And I swear I saw them like 2 days ago. glad you all stick around for the entertainment. And this is the part of the program where my spouse says, see, now if you cleaned up, you'd be able to find it. Here we go. Righto. Hashtag not sponsored. We do have a nice whiteboard. Brought to you by dryerase.com. This was actually given to me by the nice folks at Dry Erase when I was at one of their booths at a conference. I just walked up and asked, a couple of questions. They were like, yeah, no problem. Here, have a dry erase board. I'm like, sure. I think they were hoping that I was in the position of buying an entire class set, or the next time a class set came available, I would go to my dean and say, hey, these were pretty nice. And whereas that would have been nice, we're not really the right school for like, hey, buy a bunch of dry erase boards. Nothing's gotten better. Yep. I need some way to fix this, because like, let me just see. Can we go to a different? Nope. Can't go to another workspace either. We're just doomed. Sure, why not? Cracking the GRE math test from the Princeton Review. I'm not really a fan of standardized testing all that much. If you've been on this channel ever, you probably know that. Okay, GRE graduate record examinations are created and administered by the Educational Testing Service, a private for-profit corporation located in Princeton, New Jersey. ETS sounds like a scholarly organization, but in truth, it's a business that's devoted to churning out standardized tests that are inflicted on you from your high school years onward. Remember the SAT? If you need to contact ETS, here are the following addresses. I like this author. This is Stephen Leduc. GRE is a registered trademark of the Educational Testing Service, which was not involved in the production of and does not endorse the Princeton Review. In case you couldn't tell from that opening. What is the Princeton Review? The Princeton Review is a test preparation company based in New York City. We analyze actual standardized tests and use them to develop techniques for test taking. We find the test weaknesses, quirks, patterns, and pass this information on to you. So after reading this book, you'll be far better prepared to tackle ETS's tests than those people who are unfamiliar with their habits. It's fair. What is the GRE math subject test? Now, why do I need to take it? Now, keep in mind, this is from 2004, I want to say. 2002. This one was probably handed down to us. But nonetheless. The Graduate Record Examination, GRE, subject test in mathematics is taken by students who are applying for admission or a fellowship to study mathematics at graduate level. It's offered 3 times a year, April, November, and December, Graduate schools admissions committees consider your GRE subject test in addition to your undergraduate record, GPA, institution courses taken, letters of recommendation, etc. in making their decision about your application to grad school. The GRE math subject test consists of about 66 multiple choice questions that are intended to assess the knowledge and skills you've developed as an undergraduate math major. The time limit is 2 hours 50 minutes, so that you have about 2.5 minutes per question, but of course I didn't need to tell you that, math major. Each question is followed by 5 choices, A through E, and your job, of course, is to choose the right one answer and bubble it on a separate answer sheet in number 2 lead pencil. No notes, books, calculators, or scratch paper are permitted. All scratch work is done directly on the exam booklet itself. They also specifically forbid protractors and slide rules, so be sure to leave those handy items at home. If I must. Yes, I guess I'll leave my slide rules at home. How's the test scored and how well do I need to do? The computer that scores your answer sheet awards you 1 point for each correct answer, but subtracts 1/4 of a point for each wrong answer. That may or may not be true anymore. So I heard tell that the SATs no longer subtracted fractions of a point for wrong answers. The net result is called your raw score. Since there is a penalty for wrong answers, there's little to be gained by randomly guessing on a question you know nothing about. But if you're able to eliminate one or more answer choices, then it is a good strategy to guess among the remaining. Your raw score is then converted to a scaled score, which is then reported to you. Officially, the score range is between 200 and 990, but the very lowest scaled score given, something you want to avoid by the way, may be much higher than 200. The scaled score is meant to equate your performance with that of other test takers over the past 3 years, so that scores from different administrations of the test can be compared. The answer to the natural question, how well do I need to do, depends on many factors, but you can check with the admissions offices and grad schools you're planning to apply to see if they release average scores of the students they accepted from the previous year. Generally, scoring above an 850 puts you in the top quartile of test takers, and this would be considered a very good score. Finally, be aware that applying for a fellowship is more competitive than just applying for graduate admission, so you'll typically need a higher score to be granted a fellowship. Content of GRE subject test in mathematics includes pre-calculus, algebra trig, Calculus 1, limits, derivatives, integrals, etc. for functions of one variable, Calculus 2, multivariable calculus, differential equations, and linear algebra, abstract algebra, and number theory, additional topics such as set theory, probability, statistics, combinatorics, real analysis, topology, and complex variables. About half the questions on the test are in calculus and differential equations, roughly another 25% are in pre-calculus, linear algebra, abstract algebra, or number theory, and the remaining questions, the remaining 25-ish %, is going to be covered by the additional topics. Remember, they're testing you on what you learned as an undergraduate. The questions are not like those on a PhD qual exam that you might take as a graduate student. Also, because mathematics curricula vary from institution to institution, the questions are intended to cover material most undergraduates are likely to have studied, therefore specialized knowledge in, say, a new subfield of abstract algebra, no pun intended, isn't going to be on the test. Subfield is, yeah. Furthermore, you don't have to get every question right to get the maximum score, and in fact, if your raw score is 2/3 of the maximum raw score, your scaled score will generally put you in the top 25%, which right, was an 850 from the previous page. How can I prepare for this test? Naturally, it's important to be familiar with the topics, know definition statements, important theorems, and techniques for solving the most common problems. Then you must practice applying what you learned to answering questions like those you'll see on the test, many of which can look rather unconventional. This book is designed to review virtually all of the content areas covered on the test. Each chapter, except the last, is followed by sample multiple choice questions, and perhaps even more important, answers and explanations are provided for every example and question in this book. You'll learn as much, if not more, from actively reading the solutions as you will from reading the test and examples. Finally, a full-length practice test is provided with a complete explanation for every question. The difficulty level of the examples and questions in this book is at or slightly above GRE level, so if you have time and motivation to attack these questions and learn from the solutions, you should feel confident that you can do your very best on the real thing. Important strategy: do not linger over any one question. Go through the exam and answer the questions on the topics you know well, leaving the tough ones for later when you make another pass. All the questions are worth the same amount, so you don't want to run out of time and not get questions you could have answered because you spent too much time agonizing over a few difficult ones. No one's expected to answer all of them, so maximize the number you get right. Where can I get more information about the test? Yada yada yada. All sorts of stuff. I wish you all the best as you prepare for the GRE math subject test. Good luck, Steve Leduc. Chapter 1, Pre-Calculus. It's not the... Okay. It's at least showing up on my side. It's not doing anything, of course, but you know. Trying to think, like, is there anything else that could possibly be messing this all up? But I'm going to just unplug the tablet and see if that probably won't fix anything, but, you know. No. Just checking. Sometimes something weird happens. Right, Chapter 1, Pre-Calculus. Functions constitute a very important notion in mathematics, and the definition of a function becomes increasingly sophisticated as your mathematical education progresses. Very true. So a function f is going to be defined as often mapping, no, that wasn't it. Ew. Mapping A onto B or A to B. So these are going to be sets. A is a set, B is a set. A is your input, B is your output set, and usually we call these in our early pre-calculus the domain and the range. So pretty much everybody's heard of domain and range. That's what we do for input and output sets. If f assigns to the element x in A. So provided that x is in A and y is in B, we could say that f maps x to y. That's when we use that fancy arrow. It's got the one little bit on the line on this side here. So x is being mapped to y. And we also denote this as y equals f of x. Everybody's seen this before. Everybody remembers that from pre-calc. I hope. Most of the time we didn't actually use this arrow stuff, but nonetheless. Y is going to be the image of x, because as we're talking about mappings, this is going to show us that x is going to be mapped to y, and therefore it's a little bit like a hologram maybe. So like x is your real object, whereas y is the image of the object that you can see. Okay, example question. F of x is equal to negative square root of x plus 1 divided by absolute value 2x minus 1. Question A is to determine what the largest subset of the real numbers is that can serve as the domain of f. So in this case we have two conditions. One is that the denominator can't be 0. So absolute value 2x minus 1 cannot be equal to 0. Secondly, x plus 1 divided by absolute value 2x minus 1 must be greater than 0 as a whole. Okay, so the easiest way to do this one, the easiest way to do this part is, again, we're going to have to use the union of all of the possible, no, we're going to need the intersection of all of the possible domains that we're going to get from this. So with this, we're going to say, okay, if 2x minus 1 cannot be 0, then that's just going to be the same as 2x minus 1 not being 0 without the absolute values. So 2x minus 1 equals 0 will end up getting us, add 1 to both sides. 2x is equal to 1. And so x is going to be, or is not going to be, 1/2. Alright, so we have a domain restriction at the value x equals 1/2. But x could be any other value from that perspective. So just from saying, where are we going to get zeros in the denominator? The only place we could possibly get a 0 in the denominator is at x equals 1/2. Then we've got to say, well, what about this fraction thing, right? So we want to know when is this going to be positive? So this is x plus 1 divided by the absolute value of 2x minus 1. It can be right, it itself can be positive when either the numerator and denominator are positive. So that's going to be when x plus 1 is greater than 0, because the denominator is an absolute value, so it's always going to be positive. Let's see. And I don't think there's another way out of that, right? If the absolute value were not there, then you'd also have to think, when are they both negative? And if they were both negative, then they could become positive. But with the absolute value there, you can never have a negative in the denominator. And so the numerator being negative is an automatic disqualification. So this is going to be x is greater than negative 1. So x is greater than negative 1 and cannot end up being... I guess it could be equal to 0, right? Yeah, okay. Greater than or equal to 0 means that x could be greater than or equal to negative 1, with the exception of x equals 1/2. So this is going to say, in interval notation, x could be any number, right? We're going to have our domain. X could be any number from negative 1 inclusive up to 1/2 exclusive, union with 1/2 up to infinity. So we get that answer over there. That's not what I want. That answer over here. Right, x is going to go from negative 1 inclusive to 1/2, or it can be from 1/2 up to infinity, but it can't be 1/2 itself. We could also just end up putting the interval from negative 1 inclusive to infinity, and then say except 1/2. Like x cannot be 1/2. So it's an option. It all depends on what you're talking about. Who's grading? No, it's a GRE, so like... Yep, alright, got it. Cool. For the point x0 in the domain of f, it is called the fixed point if f of x0 is equal to x0 itself. This function f has exactly one rational fixed point. Where is it? Right. So, we need to take... First of all, we need to erase everything else. F at x0 is going to be equal to x0 itself. So, for this, we're going to get x0 is equal to negative square root x0 plus 1 over absolute value 2x0 minus 1. Okay, if we bring the negative to the other side and then get rid of the square root by squaring it, then, right, it's going to get rid of the negative no matter what. So we could just square both sides as it is. And then we get x0 squared is going to be equal to x0 plus 1 divided by absolute value 2x0 minus 1. Okay, and then going back up to the top here. Right. x0 squared is going to be equal to x0 plus 1 over absolute value 2x0 minus 1. Okay, if we multiply both sides by the absolute value of 2x0 minus 1, absolute value 2x0 minus 1 times x squared, but if we bring that to the other side, maybe? I think maybe I'd rather have a polynomial. So just times x0 squared. It's going to be equal to x0 plus 1. X squared is always positive, so we can actually bring that right in. Absolute value 2x0 cubed minus x0 squared. It's going to be equal to x0 plus 1. When you have an absolute value, you can say that that stuff on the inside could be positive or negative. So 2x0 cubed minus x0 squared, parentheses, is equal to x0 plus 1. That could be your plus or minus. Don't make it the other side that changes. You'll see why if we do inequalities. The definition of absolute value is that side, that stuff that you just got the absolute value off of, that stuff can be plus or minus, not the other side. So now we have two possible polynomials. 2x0 cubed minus x0 squared minus x0 minus 1 is 0. Or, if we negate that side, we can move it over to the other side. Right. Or, 2x0, like 0 equals 2x0 squared plus x0, sorry, 2x0 cubed. Right, that was a positive, and now when we move it to the other side, it becomes negative x0 squared plus x0 plus 1. So one of these two things is going to be true. Take your pick. And in fact, we really want those cubic polynomials to be potential solutions for this. Sorry, to have potential solutions, which are nice. Because in theory, right, it said rational fixed point. One rational fixed point. Right. So, we can use the rational zeros theorem from pre-calculus. Those of you who were my students, right? You were laughing at me about knowing the rational zeros theorem. This is a GRE test, right? Of course. Alright, so the rational zeros of this are going to be the factors of the final term divided by the factors of the first term and either plus or minus. So in both cases, it's going to be 1s and 2s. So it could be a 1 divided by either a 1 or a 2 and plus or minus. So we're either going to get plus or minus 1 or plus or minus a half as the only possible answers. Right. So negative, if we plug in -1, we can immediately rule it out because that's a 0 of the numerator. So that would end up making, right, this is 1, -1, 1/2, -1/2. Again, -1 is a 0 for the numerator, so -1 is just right out. Similarly, +1/2 is a 0 for the denominator and thus would be undefined. So that's right out too. So it leaves us two possibilities. I like it already. Either it's +1 or it's -1/2. +1 is going to be the easier one to try, right? So +1 would make 1 + 1 is 2. Divided by +1 in for x is going to be 2 minus 1 is 1. That's going to get us a square root of 2 and a negative square root of 2 at that equals 1. So that's not going to work either. So it has to be, by process of elimination, -1/2. But you should still check it, right? So -1/2 plus 1 is going to be 1/2. So it's negative square root of 1/2 divided by absolute value. -1/2 is going to make this a -1 minus 1 is a -2. Yes, nice. So that's going to end up being here negative, yep, square root, that sign, negative square root of 1/2 divided by -2 absolute value is just 2. So 1/2, nope, there. 1/2 divided by 2 is going to be 1/4. So negative square root of 1/4. Square root of 1/4 is 1/2. And then that gets negated, so it's -1/2 is equal to the value we had in the first place, -1/2. Right, the value we plugged in. So, yay. -1/2 equals negative square root of 1/4. Correct. Equals -1/2. Awesome. Cool. Alright, it is 11:48 and my computer is still not cooperating, so yeah, we will /raid. Because again, done does math. So thanks everybody for sticking around through this technical nonsense. I'll figure out what's going on, and we'll be back tomorrow for a differential equations class. This is Dawn. We're going to be over in Penn Center's Discord server tomorrow. Anybody who is known to the community is still welcome to join the differential equations class to sit in and like be with us on stage, as it were. To participate live in the class. If you're not interested in doing that, you can always just stick around here, or you can go into the Discord server and like still be on the chat in there. Probably recommended just to come here and chat if you're going to do that, because you know it's easy enough, and as long as the technical stuff's working, it's not a problem. But tomorrow we're going to be working on differential equations. We are at first order linear differential equations and doing slope fields. So hope to see you tomorrow. My name is Obi-Wan Pez. This is N Simplex Pachinko. We'll see you later. And anybody who's still here because this is a VOD or whatever, thank you very much. See y'all later. Now we're going to have to hard reset our system. Ugh, I hate doing this.